Hello guys, in this video we are going to discuss the solution of the problem minimum operations to make array equal. So let us look at the problem statement. So in this problem we are given two integers array num1 and num2 of equal length and an integer k is given to us. So num1 and num2 is given to us, an integer k is given to us. Let us look forward. You can perform the following operation on num1. Okay, so we are allowed to perform a particular operation on the array num1. What is that operation? Well, that operation is basically we can choose two indexes I and j and increment ith index by k and decrement jth index by k. Okay, so this is what we are allowed to do. So by performing this operation on num1 array, the problem says is that we have to transform num1 to num2. Basically, we want num1 and num2 to be equal by operating this, by performing this operation on num1 array. Okay. All right. So that's the problem statement. Now let us understand the problem statement with the help of an example. So let us take the example. So in the first example, we are given two arrays, num1, and the array contains element like 4, 3, 1 and 4, and there is a num2 array which is given to us, and the elements of num2 array is 1, 3, 7, and k which is given to us is 3. And what we need to do is basically we need to make num1 equals to num2 by performing this operation. So the operation we have to perform is basically we can choose any index I and j, and then once we have chosen an index I and j, what we are allowed to do is basically num1 of I, we can increase num1 of I by k, okay, and num1 of j, we can decrease it by k. Okay, so these are the operations which are allowed or which we can perform, and using this operation we want to transform the num1 array to num2 array. So let us see how we will be able to transform num1 array to num2 array in this particular case. So what we can do is basically, let us say we have chosen I is equals to 2 and j is equals to 0. Okay, so the elements which we have chosen here are basically I equals to let me just write down the indexes as well so it will be easier. So I is equals to 2 is what we have chosen and j equals to 0. So this index and I equals to 2, this index. Okay, and what we have to do is basically we have to, so this is our ith index, so we have to increase it by k, and we have to decrease it by k. So let us do that. So if we have chosen that, and let us say we have to decrease the jth by 3 by k equals to 3, so this becomes 1, this was 3, and let us say we have increase it by 3, so this becomes 4, and this is equals to 4. After doing this, we saw that this element becomes equals, so the 0th element becomes equal and the first element also becomes equal, right? So now the other two elements we have to make it equal. So in order to do so, we have chosen I is equals to 2 and j is equals to 3, and now let us perform the same operation. So here we have chosen these two elements. Let us perform the operation. So 1 and 3 were there. Now ith element is what, 2. So 2 we have to increase it by 3. So this becomes 7, and this we have to decrease it by 3. So this becomes 1. And after doing this becomes equals to num1 becomes equals to num2. Okay. So this is how we will be able to transform it, and let us see how many operations we have performed. Well, the number of operations we have performed is this one operation, and this is the second operation, right? So by that, the answer for this particular case will be 2. So I hope by now the problem statement would be clear. Now let us look at the brute force solution for this, and it is important that we understand the brute force solution, because using brute force solution we will be deriving the optimal solution as well. So let us discuss the brute force solution. Okay, so let us take the same case. So the num1 array which is given to us is basically 4, 3, 1 and 4. The num2 array which is given to us is basically 1, 3, 7 and 1. K is 3. So what we have to do is basically we have to transform the first array. This is the first array to the second array, right? 1, 3, 7 and 1. So this is what we want to achieve. Basically we want to transform this array, num1 array, to num2. So let us see. So first thing which we are going to do is that we are going to be on the first index. So let me just write down the indexes as well. So we will be at this index and we will check what we have to perform on this particular index, right? So what I'm trying to say is that whether we have to increase this number or decrease this number so that this becomes equals to num2 first element, right? So clearly if 4 has to become equals to 1, then what we need to perform is basically we need to we need to decrease 4 by some value, right? So since we have to decrease, remember from our question, we are at the ith index we are adding k, and at the jth index we are decreasing, or we are subtracting k from the jth index. Now since from the first index or from the 0th index we have to subtract some element, so j becomes equals to 0, right? Now once j has become equals to 0, we will proceed forward and we will see at which index am I supposed to perform an addition operation, right? So the second element, 3 and 3 are equal, so we are good there, no problem. 1 has to become equals to 7, so here we have to perform an addition operation. Since we have to perform an addition operation, so we can say I is equals to 2. Okay, after doing so, let us now perform the operation. So the first we will decrease it by k, so this becomes 1. 4 minus 3 is 1, 3, and this we have to increase it by k, so this becomes equals to 4, right? So this has become this. Now we wanted it to be equals to 1, 3, 7 and 1, right? And if you see 1 and 1 are equal, so we don't really have to bother about it. 3 and 3 are equal, right? So now we will see, now again we will see what should be our I and j. So here 4 has to become 7, so here we have to perform an addition operation. So I will be equals to 2 in this particular case, and j will be what? This we have to perform a decrease operation or a subtract operation, so j will be equals to 3. After doing so, this becomes equals to, the num1 array becomes equals to 1, 3, 7, 1, and this becomes equals to, and this was 1, 3, 7 and 1. Okay, after doing these two operations, the num1 array becomes equals to num2, and that is why we are going to return our answer as 2. Okay, so that's the first of that's the analysis of the first example. Now let us look at the second example as well. In order to understand the brute force solution bit better, let us see the second example. So in the second example, the element num1 array which is given to us is 3, 8, 5 and 2. and this we have to make equals to 2, 4, 1 and 6. Okay, and k which is given to us is 1. So let us see what we can do. So 3 has to become equals to 2, so we have to subtract some value from here. So subtract, so j is equals to 0, right? J on jth index we have to perform a subtract operation. 8 has to become equals to 4, right? So on 8 also we have to perform a subtract operation, but subtract operation is something which we have already chosen, so we will skip this. Now 5 has to become equals to 1. Here also we have to perform a subtract operation, so this also we will skip it. 2 has to become equals to 6. So in this particular case, this is where we have to perform the addition, and the jth and ith index will be this. Now let us perform the operation. So on the first index, let us decrease it by 1, and on the last index let us increase it by 1. So this is our resultant array, and this we want to transform it to 2416, which is num2, right? So here if you see, this has already become equal, so we don't really, so now one element has become equal. Now let us see the other elements. So 8 and 4, here we have to perform a decrease operation or a subtract operation, so j will be equals to 1. And on the last index we have to perform the addition operation. So now let us perform that. So 2 and j, so this becomes 7, 5 and 4. Okay, and this is 2, 4, 1 and 6. Okay, again let us see. So again j is equals to 1 here also, and I equals to 3. Now let us perform the operation. 6, 5 and 4. Oh, I'm sorry, this is not 4, this we have to increase it, so this becomes equals to 5, and this we want it to be equals to 2, 4, 1 and 6. Okay, again let us perform the same operation. So here j will be equals to 1 again, and I is equals to 3. Okay, so let us perform that. 2, now let us decrease it further, so this becomes 5, and let us increase it, so this becomes 6, and this is equals to 2, 4, 1 and 6. Okay, so now let us check the arrays. So 2 and 2 are equal, so we are good. These two elements are not equal, so that is there, and 6 and 6 has become equal, so that is okay. Now let us see what we can do. So this element, so like the element at first index 5 has to become equals to 4, so we have to perform a subtract operation here. So j is equals to 1. Let us see which index qualifies for I. So here also we have to perform a subtract operation, right? So in this particular case there is no I, right? Since there is no I, that simply means we will not be able to transform num1 to num2, and in that particular case we are going to return, so our answer will be -1. Okay, so that's the discussion about the brute force solution. I hope the brute force solution is clear, and if you want to analyze the running time complexity for the brute force solution, so the first index is clear, but for second index we have to iterate on all the remaining elements of the array, because of which the running time complexity of the brute force solution will be order of n squared. Okay, so that's about the brute force solution. Now let us see how we will be able to deduce the logic for optimal solution using this brute force solution. So now let us look at the optimal solution as well. So to understand the optimal solution, let us look at our first example. So in the first example, we had to transform num1 array to num2 array. So before we understand so let us understand various concepts which we'll be using in the brute force solution. Okay, so the first concept which I want to explain, or we want to understand, is basically so let us say in each of these operations, okay, in each of these operation I am adding some value, and the same value I am subtracting as well. So what I'm trying to say here is basically, let us say here in the first iteration, I have added some value and then I have subtracted some value, right? So what will happen? The same value I have subtracted it. So let us say there is a variable called total, and total is equals to initially 0, right? Now in total, if I'm adding, so now in this particular case, on the first case, total will be equals to what? I have added some value over here, right? Sorry, on the ith index, I have added some value. What is the value which I have added? Well, k. And then the same value I have deducted it from jth index as well. So this is equals to k. So what will be the resultant value of total? Well, the resultant value will be 0, right? Here also, if you see, total is equals to what? The same thing, we have added some value on the ith index, and the same value we have subtracted it from the jth index. So what will happen? Again, k minus k, this is equals to 0. Okay, so in this particular case, k is equal, total is equals to 0, right? So and now let us look at the second example. Here again, I have added some value and the same value I have deducted as well, so this will be 0. Here also I have added some value and then I have deducted some value, so this is 0, right? Here also I have added some value and deducted some value, so this becomes equals to 0. Then again I have added some value, deducted some value, so this becomes equals to 0, right? And in this particular case, right, when we were here, what I am able to do is basically I am able to just subtract some value, right? Ith, remember, we were not able to find out. Since ith we were not able to find out, so we were not able to perform k. The addition operation, right? We were just able to perform the subtract operation. So what will happen here? Total will not be equals to 0, total will be equals to minus k, right? So what I was trying to come up with is basically, if we have a total variable with us and with each element we are performing the operation on the total. So with each element I can either increase the value or I can decrease the value, right? So in the case I'm increasing the value, then I will also increase total by k. In the case I'm decreasing the value, I will decrease total by I'll decrease total by k, right? So if it is possible for me to transform num1 to num2, then towards the end of the iteration, the value for total will be equals to 0, right? See this? Towards the end, if we are able to perform add and subtract all the way, or we are able to transform num1 to num2, then the value for total will be 0, right? In the case the value for total is not equals to 0, it could be a positive or a negative value, doesn't matter, but as long as the value of total is not equals to 0, we are sure that we were not able to transform num1 to num2. Okay, so that's the first concept we want to understand. What is that? So the concept first which we want to understand is basically, if total is not equals to 0, then num1 is not equals to num2, right? We will not be able to transform num1 into num2. Okay, so that we have understood. Okay, so this is concept number 1. Now let us see what other things we can do with this, right? So here, if you see in the brute force solution, what we were doing is that we were trying to find a j and then we were trying to find an I, right? So basically we were at an index and we were seeing what we can do with that index, whether we can perform an addition operation or a subtract operation. And then once we are sure that okay, for this index I have to perform an addition operation, then we were moving to the next, or we were trying to find the next index where we have to perform the other operation, right? So for instance, in this particular case, j is equals to 0, so on jth we have to perform a subtract operation, and then I was looking for a position where I have to perform an addition operation, right? So in a sense, I was trying to find out I and j at the same time. But do we really have to do that? Well, what we can do is that we can iterate on one element at a time, right? So we will be just on this element. So what I'm trying to say is that we will be on the first element, and on the first element itself we will see what we have to do. Okay, so on the first element we are sure that we have to perform a subtract operation. Okay, so subtract operation we will perform. We will just do the subtract operation, and after performing the subtract operation we will move to the next index. So what I'm trying to say is that I have found a j, but once I have found a j, I don't really have to look for I will just found a j and then I will perform some operation, and the same thing, let us say, so since this is j, so what I will do is on j, so j simply means I have to perform a subtract operation. So the total will be here, we will we will set total is equals to total plus, and here we have to perform since j, so this operation, so total will be equals to minus k, right? So that's the importance of total. Basically I don't really have to look for the other operation or the complementary operation, right? I can just stick to one element at a time. I'll keep performing the right operation on that element in order to make the elements equal, and I will update my total, right? I will not worry about the ith index. I'll not worry about the complementary operation. Okay, then we will move to the next element, and then again in the next element we will do the same sort of operation. Okay, so here basically in concept 2 what I was trying to explain is, let me just write it down here. In concept 2 we just have to need to perform operation on xth index, right? So let us say we are at some index x. On that index we will just perform the operation we want to. So if the xth element of num1 is less than the num2 element, right, then we need to perform an addition operation, otherwise we have to perform a subtract operation. So we'll just be worried about the index, we will not be worried about the complementary operation, right? So let us say on the x, if x qualifies for the ith operation, right, ith operation, then we don't really have to worry about its complementary operation, which is jth. We don't, right? Because we are updating the value in total, and the total will guarantee us that towards the end, if total is equals to 0, then we were able to transform. If it is not equals to 0, then we will not be able to transform, right? Because of which at one iteration we don't really have to worry about the complementary operation. We will perform the operation at the index we are at, and we don't have to worry about the next operation what we have to do. Okay, so that's concept number 2 which we need to understand. Now let us look at one more concept. So that concept, if you see, will be clear from here, right? And what is that? So basically if you see this, so here so 7 has become equals to 6, right? 6 has become equals to, so here if you see, we wanted 8 to become equals to 4, right? 8 we wanted to transform it to 4, right? And in order, and k which is given to us in this particular case is this thing, right? So now how many operations we need to perform in order for 8 to becomes equals to 4? Well, I need to subtract k how many times? Well, I need to subtract k 4 times in order for 8 to becomes equals to 4, right? So what I am trying to say is that so in this particular case I have gone ahead here, and so I have performed multiple operations basically here. Like let's say I have performed multiple operations for 8 to become equals to 4, right? Or yeah, 8 to become equals to 4. We have performed multiple operations there. Okay, but these multiple operation I can club it, right? So what I'm trying to say is basically, let us say, and this is my concept 3, concept 3. So let us say ith index, we are at the ith index, and let us say at the ith index we have to perform a plus operation, right? So here plus operation simply means num1 of I is less than I'm so sorry, is yeah less than yeah num2 of I, right? right? That is how we have to add some values in the num1 in order for num1 to become equals to 2. That is how this ith index qualifies as the ith, and we have to perform an addition operation, right? So what we can do is basically we can calculate a diff of num2 and num2 I minus num1 I. We will calculate the diff of it, right? Now diff mod k is not equals to 0. Let us say that is the case. So let us say, right, so let me just say 8, we want 8 to become equals to 4, right? So this is my num1, this is my num1, and this is my num2. Okay, we want to make 8 equals to 8 becomes equals to 4. Okay, I'm so sorry, let me just write out the other way. I'm sorry, 4 we want to make it equals to 8. Let us say that. Okay, so this is my first array, this is my second array, right? Here 4 is less than equals to 8, which is fine, and let us say the k which is given to us is 3. So now the difference between these two elements is what? 4, and k which is given to us is 3. Now is it possible for me to add or subtract k to the first index, right? So basically I can do this 4 plus 3 minus 3 plus 3, that is what I can do, right? But it is possible for me to perform this operation and bring this to 8, make this 8. Well, it is not possible, right? Because I am increasing it, I can increase or decrease the value in a step of 3, and here the diff is 4, right? If it is if the difference is multiple of k, then only I will be able to achieve, or I will be able to increase num1 value, and I'll be able to make it equals to num2 value. But if it is not a multiple of k, which is what I am trying to find out from here, if diff is not a multiple of k, so modulus k is not equals to 0, then it is not possible for me to change num1 to num2. Okay, and in that particular case we are going to return minus 1. Okay, it is not possible in that case. Okay, so these are the three concepts which we need to understand, and once we have understood these three concepts, the problem becomes very simple, or to solve this problem becomes very simple. So let us try to understand it through an example. So we had our first array. So the first array which is given to us is basically 4, 3, 1 and 4, and let me just have it like this. Okay, and yeah, and the second array which is with us is 1, 3, 7 and 1, and k which is given to us is 3. And let's just write down the indexes: 0, 1, 2, 3, 0, 1, 2 and 3. So what we are going to do is basically we will iterate, right? So we will start from the first index, so I is equals to 0. What we are going to do is we are going to compute the difference between the this index, right? So we are at this position, so we are going to compute the difference between them. So here 4 minus 1, right? So 3. Okay, now what we are going to check is so 3. Now what we are going to check is basically we are going to check whether diff modulo k, so k is 3, is not equals to 0. Well, 3 modulo 3 is equals to 0, right? So this condition is not satisfied. Since this condition, so this is our concept 3, remember this, right? So since this condition is not satisfied, this condition is not satisfied, we will be able to transform it, right? Now once we will be able to transform it, we will see how many steps we are going to do. Well, what the number of steps is equals to, so let us say we will have a count variable, and initially the count variable is 0, which will contain the number of steps. So the number of steps is equals to basically count is equals to count plus, let us see how many steps we have to perform on this element in order for this to become equals to this. So what we have to do is basically diff divided by k. These many steps, and this will be an int. These many steps I need to perform. So diff is 3, 3 divided by 3 is 1. So here the number of steps I need to perform is 1. Okay, so the count will be equals to 1. And let's not forget about our total. So total here we have added it, so this becomes equals to 3. Okay, now after doing that, I is equals to 1, we move to the next element. Next element, again we have computed diff. So here diff is equals to what? So the next element is this now, right? So diff is equals to 3 minus 3, which is equals to 0. Since 0 simply means that the elements are already equal. Since the elements are already equal, we don't really have to perform any operation. So what we will do is that we will move to the next element in this particular case, right? So now we will move to 2. So now we are at this position. Okay, so here what will be the difference? Well, the difference will be 1 minus 7, right? And 1 minus 7 is equals to minus 6. So difference could be negative, positive, it doesn't matter. Okay, so difference is equals to minus 6. Now we will check whether diff is a multiple of k. Well, diff is a multiple of k, so this condition is satisfied, right? Since this condition, so diff, like here it is a multiple of k, which simply means I'll be able to transform it. So since I am able to transform it, so now let us count the number of steps we will need. Well, count is equals to, remember from our above case, plus integer of, and this thing I have forgot about here is basically absolute, right? We have to take absolute of diff, right? So here what will happen? Count is equals to 1, and 6 divided by 3, so this will be 1 plus 2 steps, right? So count will be 3, right? So here in this particular case, count will be equals to 3. And let us update our total also. So what we have done is total, remember here total was 3, so 3 minus 6, and this becomes equals to minus 3. Okay, once we have done that, we will proceed forward, and in this particular case I is equals to 3. Now we are at the third index, so the third index is this 4 and 1. So let us compute the diff. 4 minus 1, which is equals to 3, right? Now the other thing, 3 is a multiple of, right? So diff, whether diff is a multiple of 3 or not, right? So this is a multiple of 3, so we will be able to transform it. Once we are able to transform it, we will check the number of steps. So the number of steps equals to count plus, okay, and let's take the 3 divided by 3, right? So the count is equals to 4. Okay, now once we have done that, what we will do is basically we will update our total. So total was initially minus 3, and we need to add 3 to it, diff, so this becomes equals to 0. And after doing that, we have sort of transformed num1 into num1 to num2, and here we can see that total is equals to 0. So what we are going to do is basically we are going to return this value, right? And count, it's not just the count divided by 2, please remember that, right? And the reason why, because in one iteration I can perform add and subtract both, but in this particular case I am iterating on one element at a time, and then I am increasing or then I am increasing my count, right? Because of which I will be counting the same or the operation twice, right? I and j, I'm counting it as separate operation, but it is actually the same operation, right? That is why we are going to do count by 2. So that's the explanation, folks, and the the running time complexity, as it is evident, is order of n, and the space complexity, we have not used any space complexity, so that's a constant space. Okay, so that's about the explanation, folks. Now let's switch to our coding section and code it out. So I have already coded it, and let's look at the code. So there is a count which is equals to 0, which holds the answer. Total is equals to 0, and then I have iterated on one element at a time. Okay, the first thing I did is computed a diff between those two elements, and if the elements are identical, so the difference will be 0, then we will continue to the next element. We don't have to perform any operation. If there is a diff, right? So if difference is not equals to 0 and k equals to 0, so this I have not covered in my explanation, but this is rather simple. If there exists a diff and k is equals to 0, right? So in that particular case, we will never be able to transform the element, right? Num1 to num2, because the element differs, but k is equals to 0. We are not able to perform anything, right? So in that particular case, return of -1. And this case, can we make it identical or not? If we can make it, then diff has to be a multiple of k. If it is not a multiple of k, then we need to return -1 from there itself. Otherwise, we are going to increase count by this, right? The number of steps. And then the total is equals to total plus diff. After doing so, if total is not equals to 0, then we need to return -1. Otherwise, just return half of count. So that's the code, folks. Now let us submit our solution. So our code got accepted. So that's about the video, folks. In case if you have any confusion regarding this, please feel free to drop in the comment section and I'll try to address them. Thank you.